Hi everyone, my name is Lorenzo Ochoa, and today I'll be presenting the image that you see in the screen titled Adrenaline Rush Pathways into the Brain. Imagine yourself driving on the road on a busy day during traffic hour. You are paying attention, but not really paying attention. You're driving slow and fast, just a typical day in traffic. Suddenly, you hear a loud noise in the distance. This loud noise now shifts your entire attention to what is going on. And now you are very aware of what is going on, when is it happening, where is it happening, and what exactly is happening. This loud noise activated the adrenaline center of the brain, which is a normal response to a stressful situation that we all have and we all live with every day. This is something that evolved over time that has made us more capable of responding to stressful things such as an accident in the road or other things that may elicit a response of stress. This is due to the adrenaline center of the brain called the locus coeruleus. And for sure, I'll just be saying adrenaline center. But in this small center in the brainstem of our brains is the region that controls alertness, attention, and stress responses. Even though it's a small region, it is very well connected to every part of the brain, as you can see in the image to the left. This region coordinates many actions such as alert, attention, and stress, like I mentioned. However, when we stress ourselves often, so repeated activation of this can get stuck in overdrive. So meaning that we can keep stressing it, and over time, this can start creating issues. And this can lead to detrimental health effects in the body. As an example, one such detrimental effect is Alzheimer's disease. So we know that Alzheimer's disease affects the brain. This is a disease that we all know, unfortunately, a lot about it because it affects many people in our lives. It could affect many people in our lives or people that we've heard in media or in other places. So the adrenaline center is involved in Alzheimer's disease because it's been shown that it is the first region to show signs of neurodegeneration, even before the loss of memory starts to become obvious in people. This can even be seen 10 years before we start seeing other types of symptoms that we normally use to characterize Alzheimer's disease. So this region, as I mentioned before, is very well connected to everything. This includes the memory center of the brain, the hippocampus. And as such, it can be an important region to be able to start looking into things. Most of the Alzheimer's research currently focuses on plaque, tangles, and other types of signs of Alzheimer's disease that typically come way after the symptoms have already started. So by looking into this region, we are now focusing in a region that is a lot less studied, but could give us a lot of information in how the disease progresses. And so how are we studying this region? We are using cutting edge technologies such as engineered viruses. These are not the type of viruses that get you sick, but these are viruses that we engineer in the lab to do things that we want them to do, such as express fluorescent signals, and we can visualize using other types of instruments. So if you can imagine, you can shine a light at the brain for this example, and we'll get a fluorescent signal back of it. We combine this with tissue transformation methods. What these methods do is they transform the tissue into something that we can now work with and start doing a lot of different experiments that were not possible before. As you can see here, we can turn a normal brain into a completely transparent brain. Now we can see deeper into the brain without having to cut it into little pieces. We then incorporate advanced imaging techniques to visualize these things. So now that we have a transparent brain, we need to be able to visualize it. What can we see? How are we using this technology? And how are we gonna analyze this technology. So we can create 3D models of the brain using these techniques, and we can combine it with machine learning algorithms. So now by using all these technologies, we can start developing information about the brain that we're not previously able to do with classical techniques. And we use all this to put together a picture of what is happening in the adrenaline center of the brain. And so this award winning image is a representation of our work, all the work that we've come together and to present here has given us this beautiful pictures that you see here. So we know that the adrenaline center links to stress, memory, and attention. Now we've also found out that this is one of the first regions that affects Alzheimer's disease, is affected by Alzheimer's disease, and understanding the decline can reveal new treatments and targets. And our research maps brain connections in unprecedented detail. And just to point to a little detail here, if you look at to your left, you can see the adrenaline center right here on this region at the bottom. This very bright spot is actually the locus coeruleus. And if you see this region, you can start seeing a lot of fibers, thin little fibers that are coming out of it and going here to this region on the right. This is the hippocampus, the memory formation center of the brain. By using the techniques that I mentioned, we were able to target these two regions and map the projections to and from this region to be able to tell what is going on and how we can address this type of insult by Alzheimer's disease. I would like to thank this Chung Lab, especially my mentor, Kwang Hung Chung, and everyone in the lab because this is a very collaborative effort, and we all work together to bring these beautiful images to the public and to, of course, to the community of science. Also, would like to thank the Peak Hour Postdoctoral Fellowship for funding my postdoctoral career here, and of course, the NIH grant that has made this work possible. Thank you.